Let's go over Test 2 tutorial. This goes along with your practice homework assignment for our Test 2 in Math 1314, which is our proctored exam. Now this first problem asks you to graph. Before you can determine the graph, you need to complete the XY chart. If you notice we have x squared and you remember the basic graphing shapes, you will remember this is a parabola, always. So we know right off the bat that A nor D would be the solutions here. Now one by one, take the x values, substitute into the equation. So I have y equals -3 squared minus 6. If you put this in a calculator, handy hint, be sure to use parentheses around those negative numbers to get the correct sign, because this is really a 9 minus 6, which is equal to 3. Easy to get the wrong answer on the calculator if you don't use the parentheses. Quickly plugging in the rest of the numbers, if I have -2 squared minus 6, that's 4 minus 6, which is -2. If I substitute in -1 squared is 1, 1 minus 6 is -5. 0 squared is 0, minus 6 is -6. 1 squared is 1, minus 6 is -5. +2 squared is 4, minus 6 is -2. +3 squared is 9, minus 6 is +3. Now, we must find the parabola that matches up to these ordered pairs. So check them. The first ordered pair I noticed would be easy to check is 0, -6. In answer choice B, I do have 0, -6 on that parabola. However, in answer choice C, 0, -6 is not a point on the graph. So my correct answer. Now in this question, you will simply solve. Start off with the distributive property. The distributive property says to take the number in front of any parentheses and multiply. So we end up with 4x minus 8 and bring down the plus 15 equals. Then on the other side of the equals, I multiply through and I get 3x plus 12. Now we have to get x by itself and isolate it. First, I notice I have like terms, so I combine those, bring down the equal sign in a straight line if at all possible. Now notice that I have x terms on both sides of the equation. You want to try to get those on the same side. So I will subtract the 3x, in other words, move it over, and 4 minus 3 will give me 1x. But then to isolate that x, I would need to move that 7 over, which in essence subtracts it. So x is equal to 5. That would be my solution. When I come up here, I would choose answer choice A and type in the 5. Now for this problem, before we solve it, we will use the least common denominator like previously, but notice there are x's in the denominator. We have to find out what the restrictions are. Restrictions are going to be, what are the values that make that denominator 0? If you look at the first one, 4 minus 4 would give me 0. So I don't want to use a 4. 4 must be a restriction. If you look at the second one, fraction, -7 plus 7 would give me 0. I don't want that to happen. So there are 2 restrictions so far. Now when you look at this third one, it's a trinomial. It's kind of hard and difficult to tell what would give you 0. So go ahead and factor that. So factor that trinomial and we'll get x minus 4 and x plus 7, which if you did the FOIL method would indeed be that trinomial. These two are the same as choice 1 and 2 in the first 2 fractions. So I see that my restrictions would be +4 and -7. After you type in the restrictions, then you solve. We're going to use a common denominator of x minus 4 and x plus 7. We will use this around every value, every term, x minus 4, x plus 7, x minus 4, x plus 7. Now in the first fraction, the x minus 4 would cross cancel and divide out. That just leaves you that number 1 and the x plus 7. Then I have, in the second fraction, the x plus 7 cancels out, and that leaves me a minus with that 5 and the x minus 4. In the last fraction, all of this cancels because remember the trinomial is the same thing as those two factors. So I'm only left with 11. Now I will multiply and distribute. I end up with 1x plus 7 minus 5x plus 20. Now if I combine like terms, I end up with negative 4x plus 27 equals 11. Now I must solve for x. If I move over the 27 and subtract it, then I have negative 4x equals negative 16. Then I will divide by negative 4. X is equal to 4. Well, it looks like that's a fine answer, but notice, whoa, that was one of my restrictions. If your answer is the same as a restriction, then omit and discard that answer. Go ahead and choose C, the solution set is empty. Now here's another good consumer problem where you want to invest some money. You're going to take $21,000 and break it down into two different investments. A lot of financial experts tell you to diversify your investments. So one bank or some type of savings must be paying 8% and another is paying 9%, which are both great at this time. All right, if the total interest earned was $18.50, so if the interest is $18.50, how much did we put at each one of these rates? We'll refer back to your formula sheet for the word problem applications again. What we'll see is we have rate number 1, which is 8%, times x, which would be our first amount, plus rate number 2, which is 9%, times the total money, $21,000, minus x. That's the amount you put in the 8% account. And that's going to equal to the interest earned. Now let's go ahead and solve. Change these percents to decimals, and your equation will look like this, having the decimal representations. Then you will need to use a distributive property to multiply with that 0.09. So 21,000 times 0.09 is going to give me 1890, and 0.09 times that x looks like this. Now, when we combine our like terms with the x, that will give me a negative 0.01x plus 1890 equals 1850. To solve it, just subtract the 1890 on both sides. I have negative 0.01x equals negative 40. And now divide by that negative decimal number. So x will equal 4,000. Now the x was the amount that was paired with 8%. So that 4,000 will be the answer for the first account because the first account was 8%. To get the second amount at the second 9% account, take your total, 21,000, and subtract the 4,000. That will leave you with $17,000, which went into the second account at 9%. Now in this question, you're going to be calculating a charge for a taxi cab. City cabs will charge a $2.50 pickup fee and $1.75 per mile. So their fee is $2.50, that's the fixed cost if you refer to the formula sheet, and $1.75 per mile, that's the variable cost because the more miles you go, the higher that will be. Now Diego took this cab, and to go downtown his charge was $30.50. So his fee was $30.50. How far did he travel? So we're looking for the distance. The distance would be the miles. So we're going to go ahead and let miles be our unknown x. So let's go ahead and translate that into algebra, and it looks like this. When I solve, I subtract 250. That will give me 28 equals 1.75x. Divide by the 1.75. And if I do that, 28 divided by 1.75, I end up with 16. So he had to have traveled 16 miles. Now in this question, you don't actually get a number answer. You will be solving a formula for the specified variable. We want to solve for the n, so get n by itself. To get n by itself, we can simply divide by 4 pi. So n is equal to a divided by 4 pi. That's what you would type in. We want to go ahead and take the square root of 294 and simplify that a bit. One way to do that is with a factor tree, and it's good to see what perfect square number would divide into 294. Let me go ahead and take 294 and divide by 4, and that does not divide evenly. So 294 divided by 9, which is the next perfect square number, does not divide evenly. 294 divided by 16, which is another perfect square number, does not divide. 294 divided by 25 does not divide. 294 divided by 36 does not divide. 294 divided by 49 does divide evenly. So I could say 294 is equal to 49 times 6. And 49 is a perfect square, 7 times 7. So we would simplify this by bringing the 7 in front of my square root symbol, and the 6, which is the leftover remainder factor, it's not a perfect square, it goes underneath the radical symbol. So my answer is 7 square root of 6. In this problem, we want to rationalize the denominator, which means to get the radical symbol out of the bottom and move it into the top. So I can simply multiply numerator and denominator, top and bottom, by the square root of 29. When I multiply straight across, I get the square root of 29 on the top. And then when I multiply the 29s on the bottom, I get the square root of 841, but that is the same thing as just 29. Now this is my final answer because the square root of 29 over 29 will not reduce any further. So that's answer choice B. Now I want to find the product. I can use either the distributive property or the FOIL method. First, outer, inner, last. I'll show you the FOIL method. If I take the first two terms in each parentheses and multiply those together, I get x squared. That's what we call the F in FOIL. Then, if I go back and multiply the outer two terms on the outer edges of each parentheses, that would be the x times 8, which is 8x, and that would be a positive. Then I go to the middle of my problem, which would basically put me with my innermost terms. That would be the minus 12 times the x, which does give me a negative 12x. And last but not least is the L. The L stands for last, and that would be my terms negative 12 times 8, because they're the last two terms in each parentheses, which gives me negative 96. Combine your middle terms to get x squared minus 4x minus 96 as my final answer. Now for here we have complex values again, but we're trying to find the product or multiply. To multiply these two, since they are binomials, we will use the FOIL method. First, outer, inner, last. So let's do this. Negative 3 times 7. Negative 3 times 7 is negative 21. Then we'll take, that's the first, my first term. Then we'll take the negative 3 times the I on the outer edges. So negative 3 times I would just be minus 3I. Now we'll go to the innermost terms. 5I times 7 is 35I. Since it's positive, I'll put a plus, and that's the innermost terms. Last but not least, I'll multiply the last terms. That would be 5I times I, which is 5I squared. And I'll again put a plus sign. Now, if you notice, we have like terms in the center, so combine those. That will give me 32I. Now, the I squared was given as a definition to always equal negative 1. So substitute in negative 1 in place of I squared and multiply. That will now give you a minus 5. Combine the negative 21 minus 5, and that would be negative 26 plus 32I. Be careful to always list the I term last. Now here we have a division problem, so we must use what's called the conjugate. The conjugate would be the identical two terms that are in the bottom except for the middle sign. So the proper way to simplify would take the conjugate, which is 9 plus I, and multiply that through in the numerator and denominator. When we multiply in the numerator, we will simply distribute. So I end up with 72 plus 8I. However, when we multiply in the denominator, you have to do the FOIL method. Because we are multiplying two conjugates, though, the outer and inner terms will always cancel out. So a shortcut would be just multiply the first two terms and then the last two terms. So 9 times 9 is 81, and negative I times positive I is negative I squared. Now remember, I squared is negative 1 itself, which gives us a double negative in the bottom, becomes positive, which would be 82 in the denominator. Now don't leave this as the final answer. We want A plus BI form. So take each term in the top, 72, put that over 82, then take that 8I, put that over 82, and let's go ahead and reduce. When I reduce the 72 over 82, you can simply divide by each by 2. You will end up with 36 over 41. Then, when I reduce 8 over 82, again, just divide each by 2. That will give me 4I over 41. Or you could write the I separately to the right. That is the final answer. Here on number 12, I want to factor out the greatest common factor, which is also abbreviated as the GCF. So if I look at 21 and 14, I know that the number 7 will divide each evenly. I also see that each term has the variable x in it. So I take the 21x squared and divide by 7x, and I take the positive 14x and divide by 7x. Well, 21 divided by 7 is 3. X squared divided by x leaves a single x. 14 divided by 7 is 2. And then the x's cancel out when you divide. So my answer would be 7x, open parentheses, 3x plus 2, close parentheses. On this question, you want to use the factor method for solving quadratic equations. First, we need to write every term on the left-hand side of the equal sign. So this positive 5 gets subtracted on both sides of the equals. Now we have a trinomial. So I'm going to factor that trinomial. I have 2x times x will give me 2x squared. And then this 5 is actually 1 times a negative 5 as factors. So let me go ahead and try a positive 1 and a negative 5. I need to make sure that this is the right combination. So let me multiply my outer terms to get negative 10x, multiply my innermost terms to get a positive 1x, and if you combine these like terms, you see a negative 9x, and that is my middle term. That's how I know my factoring is correct. So I've double-checked that. After you correctly factor this trinomial, you take each factor and you set it equal to 0. Then you will solve it for x. On my first one, I would subtract my 1, and then I'll divide by my 2. So my first solution is a negative 1/2. On my second factor, I can basically look at that and tell that that is a positive 5, because 5 minus 5 gives me 0. So I check my answer choices and look for the negative 1/2 and the positive 5, answer choice D. In this equation, you're asked to use the square root property, which is still yet another method of solving quadratic equations. With a square root property equation, you need to isolate the square term. So I'm going to go ahead and divide both sides by 3, and I get x squared equals 25. Now I will take the square root of both sides. Now the square root and the exponent 2 cancel, leaving x, and we know the square root of 25 is 5. However, with the square root method, you should be getting 2 answers. So as soon as you take this square root on the right-hand side, insert the plus minus symbol. Remember, plus minus means positive and negative. So when you go to type this answer in, you could type in a positive 5, comma, a negative 5. The order doesn't really matter. Here on question 15, we're asked to use completing the square method for solving a quadratic equation. So what we want to do is take our trinomial and break that down. I want to move the constant term, the positive 20, over, which means subtract it. It'll be a negative 20 on the right-hand side of the problem. And that will only leave a binomial on the left. That's what we want to have to set this up. You also want the x squared to just be a 1x squared, and it is an understood 1. Next is where the magic happens. You take the x coefficient, which is negative 8, and the very first thing you do is divide that by 2. You will always divide by 2, and here I get a negative 4. Then next, whatever you get, you square that quantity. So negative 4 squared is equal to 16. 16 is my special magic number. I take that 16 and I'm going to plug it back in behind the binomial, making that a trinomial. And then I'm going to plug that 16 in behind the negative 20, because what you do on one side of an equation, you're supposed to do on the other. What we have now created is a perfect square trinomial. So here's what we have. We have our perfect square trinomial on the left, and negative 20 plus 16 is going to be negative 4 on the right. A perfect square trinomial will always factor as a quantity squared. So I know it's going to be x, and if you think back, what had given me that 16, that was a negative 4 times negative 4. So my factor is x minus 4 quantity squared. Now I can take the square root of both sides, and I get x minus 4 equals plus minus. Remember to do plus minus. And the square root of negative 4 is 2i. We use the I because the 4 is negative here. Now all I have to do is move this negative 4 over. which means I have a positive 4 plus minus 2i. That's my solution. So I go over here to my answer choices, and that would be answer choice B. In this question, we are asked to use the quadratic formula that you'll see in the upper right-hand corner. Now, when using the formula, you choose the numbers to plug in for A, B, and C. A is always the number in front of the x squared, so that's going to be a 1 in this case. B is always the number in front of x. In this case, I have a 5. C is always the constant number. It'll be the third number in that trinomial on the left, and it has no x variable, so C is also 5 for my question. Now I substitute into this formula. I have negative 5 plus minus square root 5 squared minus 4 times the A, which is 1, times the C, which is 5, all divided by 2 times A, which is 1. When I simplify, I have negative 5 plus minus square root 25 minus 20 all over 2. Now, some people ask, Ms. Stewart, where'd you get the 20? These last numbers, the 4AC, you will always multiply those together when you're simplifying it, like I am. Now I have negative 5 plus minus square root 5 over 2 after I do the subtraction and simplify. If I look closely at my answer choices, I need a negative 5, positive square root 5, and a negative 5 minus square root 5, both over 2. That's my answer choice A. In this question, you actually use the Pythagorean theorem because we have a situation that forms a right triangle. Our situation is this. The ladder is leaned against a wall. This ladder is 26 feet long, and it is 10 feet from the base of this wall, and we want to know how far up the wall does this go. You see it forms a right triangle. According to the Pythagorean theorem, we know a squared plus b squared equals c squared. The a and the b are going to be your sides along that right angle. The c is always your hypotenuse. You can tell the hypotenuse because it's going to be the diagonal side, opposite that right angle. Now we plug in our numbers. One side is 10, but the other side is the wall. I don't know what it is. The angled or diagonal side is 26. Now I'll work this out, simplify, and if I subtract my 100 on both sides, then I can take the square root of both sides, and then I will get 24. That would be the answer in this case. Here on number 18, we're solving a system of equations, which means to solve two equations at the same time, simultaneously. We want to use the substitution method. So take the second equation that is solved for y and substitute that quantity in for the y. So here's what we get. We have x minus 3, but instead of y, we substitute in negative 2x plus 10, and that's equal to negative 2. Notice our y became that negative 2x plus 10. Now we distribute, so I have positive 6x minus 30. I can combine my like terms. I add the 30 to both sides. So move that 30 over, it'll be a plus 30. And now that I've added that 30, I get 28. And I would divide both sides by 7. X is equal to 4. Now, if x is equal to 4, then we take that second equation again, and this time we substitute the 4 in for the x. So negative 2 times 4 plus 10 be negative 8 plus 10, which is equal to 2. Now, you have to type this in to My Math Lab as an ordered pair because the directions state that. When you type an ordered pair, you must use parentheses, x term, comma, y term, close parentheses. In our last question of the homework tutorial, we are asked to solve this system by the addition method. With the addition method, we combine the like terms in order to cancel either the x or the y. But none of these, well, yes, I would have one that canceled out right here. I was about to say none did, but it does. Here, my 13 and my negative 13 cancel out. 2x plus 4x is 6x. 2 plus 4 is 6. So now I will take the 6x equals 6 and solve. I get x equals 1. After I have one answer, I now use substitution to get the second half of this answer. Let me take that first equation this time. And I'm going to substitute in a 1 for the x because I know that was my answer. So I have 2 plus 13y equals 2. I subtract that 2 on both sides, 13y equals 0. So y equals 0 when I divide. So my answer is an ordered pair, parentheses 1, comma 0, close parentheses. Hope that this helps you in your studies.